Okay, so we have this first one. It says, giving a test to a group of students, the grades and genders are summarized below. Find the probability that a student was not a female that got an A. So whenever you're trying to find the probability of something not happening, it's often easier to figure out the probability of that thing happening and then using the complement formula to figure out the probability of it not happening. So let's ignore this not and first find the probability of finding a female that did get an A. Probability of female and A. Well, of the total group, there's 75 people total. How many of them were females who got an A? Well, here's the A's, here's the females, so there's just 5. So 5 of 75. You can reduce that if you want in your head, or you can use the calculator. You're just going to go hit your fraction the way it's written, 5 divided by 75. We're going to hit math and then enter twice. This is the same thing as 1 over 15. Well, that's the probability of finding a female and that person having an A. The probability of female that got an A. But I want to find the complement. So you can write that like this. The probability of female and A. And a bar on top symbolizes not that, the complement. Well, let's say, I was talking about the weather. If there was a 30% chance of rain, what's the percent chance of not rain? Well, that's just the remaining percent. That's going to be 100 minus 30%, which will give me 70%. Same with fractions. If this was a fraction, there's a 3 out of 10 chance that it'll rain. If I want to find not rain, I'll subtract that from 100% or 1 and get 7 out of 10 chance that it will not rain. So if there's a 1 in 15 chance of picking a female who got an A, the probability of not picking a female who got an A is going to be the rest, 14 out of 15. I'm just going to do 1 minus 1 over 15. So there's your answer. Okay, 22. This says the table summarizes the results from 978 pedestrian deaths that were caused by automobile accidents. Here's our data. It says if 2 different pedestrian deaths are randomly selected, find the probability that they both involved pedestrians that were intoxicated. So we'll say the probability of ped intox and ped intox. Okay. So the likelihood that the first pedestrian is intoxicated has no effect that the second pedestrian is intoxicated. So these are independent events. So the probability that the first pedestrian is intoxicated, well, of all of these incidences, how many incidents had pedestrians that were intoxicated? Well, we're just going to add up the results from the yes column for that. 57 plus 223 is 280. So this is going to be 280 divided by the total, 978. Of the 978 accidents, 280 of them involved pedestrians who were intoxicated. And probability, we're just going to multiply. Same thing here. Probability the second one was intoxicated is 280 out of 978. So we can do that in the calculator. Hopefully this will work. Oh yeah, we want a percentage, so we don't need to find the fraction. 280. Oops, get out of there. Clear. 2. Nope. Oh, that's why my number lock. Okay. 280 divided by 978 times 280 divided by 978. We get 0.0819, a percentage. Move that decimal place 2 places to the right with 1 decimal place accuracy would be 8.19 or 8.2%. Okay, question 23. Giving a test to a group of students, the grades and genders are summarized below. Yada, yada, yada. If one student's chosen at random, find the probability that the student was male or received a grade of C. So, probability of male or C. We're going to use the or probability from the notes. So this is going to be equal to the probability of a male plus the probability of C minus the probability of both, because we'll double count. So the probability of picking a male from this group, well, there's 62 people total. Probability of picking a male, there's 28 males. Plus the probability of picking someone with a C, 62 people total. A C, 25 people got a C. So if you'll notice, the first number, 28 over 62, I got the 28 by adding up all the males. The second number, 25 over 62, I got 25 by adding up all the C students. But you should notice that I copied or I counted a group twice. Namely, the males who got a C. So I have to subtract that off. I counted that group twice. Minus 6 out of 62. So this is going to be 28 plus 25 is 53. Minus 6 is 47 out of 62. Four decimal places, 47 divided by 62. Oops, 47 divided by 62. 0.7581. Okay. And the last one. It says a card is drawn randomly from a deck of 52 cards. Find the probability of the given event. The card is a face card. So out of 52 cards, how many are face cards? Well, you have the jack, queen, and king of each suit. So there's 3 that are diamonds, 3 that are spades, 3 that are clubs, 3 that are hearts. So that means I have 12. So the top number was right, but it's 12 cards that are face cards out of the entire deck, which is 52. This will give me 1 over, not 1 over, that's not right. It will be 3 over 13. Okay. Again, you can do that in the calculator. 12 divided by 50. Whoops, this thing keeps shutting off on me. 12 divided by 52. Darn it. Clear that. 12 divided by 52. Math. Enter, enter. 3 over 13. And you're good to go.